Are you with us? What's your question?
Are we going to do we do the example?
All right, so does anybody need this one that's about a conical pile? This was on homework.
I don't think I have that.
Okay.
I don't remember that.
Okay. Yeah, I don't remember which of them. I feel like it was on the homework last night because I put current problem, not last night. Okay, so what about this one?
Yeah.
Okay, so can you tell me why you might have struggled with this?
Well, that one I felt like was the easy one because you did like inverse tan of square root of 3 minus inverse tan of 0. Got the answer, something like that. But like the other ones were hard ones.
Okay. Marasia, do you need to look at this one? Okay. Kat? Okay. This artillery one was another one that somebody asked about.
I didn't understand what they were asking for.
Okay.
How do you put inverse of like cotangent in your calculator?
It depends on which kind of calculator you have.
I have the 84.
Okay. So on the 84, if you want the cotan inverse of square root 3, okay, you're going to do the tan inverse. Can you figure out why you do tan?
Okay.
Can you think about why you might use tan?
If they're like opposite.
So you do the tan inverse of 1 over the square root of 3. So you do the reciprocal function with a reciprocal value.
Okay. So I should have done like 1 over like that whole little equation.
Yes. Okay, so flip or you could have just flipped the numerator and denominator, which is what we do here. Think about the fact that square root of 3 is really square root 3 over 1, so we flip it. So on this one, you just want to flip those over. Okay. Do you need more than that? Okay. And then number 11, I guess, was also on there.
Yeah, that one was hard.
Okay. So if all the solutions of a trig equation are given by the formula, remember we've written answers like this before, right? So pi over 6 is a solution. What does plus 2k pi mean? And so they want to know which of these guys would not be solutions. So in other words, which one of these is not something you would get by adding 2k pi to pi over 6 or to 11 pi over 6. Okay. So you could do it two different ways. You could start with pi over 6 and then you could add multiples of 2 pi. Think about the fact that our denominator is 6. So if we want to add multiples of 2 pi, we want to have the same denominator. So if 2 pi is the same as 2 pi over 1, and if I multiply 1 by 6, I get 6. And so 2 pi times 6 is 12 pi. So we can either add this repeatedly to pi over 6 and 11 pi over 6, or we can subtract it repeatedly from the values that we have here in the problem. Okay, either of those things would work. Does that make sense? Abby, you have a...
So the answer would be C, which is not a solution?
I think C is, because if I add 12 pi over 6 to 1 pi over 6, I get 13 pi over 6. So that is a solution. Oh, does that make sense? If I add 12 pi over 6 to 11 pi over 6, I'm going to get 23 pi over 6. If I add, let's see, if I have 23 pi over 6 and I add another 12 pi over 6, that's going to give me 35 pi over 6. So the only one that I can't get by adding 12 pi over 6 is 7 pi over 6. So that's the one that is not a solution. Right, so if we take a look at number 2, in all these problems like this that seem like they're really hard, they're not expecting you to figure out what is the equation that represents this. They're giving you the equation, and your job is to kind of understand the equation, to read it carefully, to look at the things they say. So it says that a projectile fired into the first quadrant from the origin of a coordinate system. So I'm going to fire the projectile from right here, and I'm going to fire it into the first quadrant. And at various times, it's going to be at various positions, and we're going to denote those systems with XY. So it's at a point XY at time t. According to the relationship, the cotangent of theta is equal to 2 times x over 2 times y plus g times t squared, where theta is the angle of elevation of the launcher and g is acceleration due to gravity. Now notice, like, you would think acceleration due to gravity is a constant. Why didn't they just put that in the formula? But this formula would actually work no matter what planet you were on. And so different planets have different accelerations due to gravity, and so sometimes they'll say like on the moon or on Mars or at some strange place, okay? So we want to put 32.2 into that equation in place of g. So we've got cotangent of theta equals 2x over 2y plus 32.2 t squared. An artilleryman is firing at an enemy bunker located 2,675 feet up the side of a hill that is 6,325 feet away. So when they're giving you these two numbers, how do those numbers fit into our equation in our picture? What do those two numbers represent? Kat? So if it's it'd be other way around, because this one is up and this one is away, and so 6,325 is our x and 2,675 is our y, and he fires around, and 2.36 seconds later, so they even give us t, he makes a direct hit. Okay, so the only thing that they're asking us to find is the angle of elevation. So they want to know this. They gave us this, they gave us this, they gave us this. Okay, so we'd have to fill those all in, and then we would take the cotangent inverse of both sides of that equation. Okay? All right, the second part says, if the angle of elevation is also given by this other equation, where v sub 0 is the muzzle velocity of the weapon, find the muzzle velocity of the piece of artillery he used. Okay? I'm sorry? V sub 0 is initial velocity. That's like how fast it was going when it left the thing that was projecting it. Does that make sense? Right? So, do we know what theta is? Yes, because we found theta in the first part of the problem. So, secant of theta becomes a number. We already know what t is. We already know what x is. So, in this equation, we would just be solving for v sub 0, just using information that the problem gave us or information we solved for in part A. Okay. All right, so we want to solve the cosine of 3 times theta equals -1. Okay, so this is an example of a place where I would use u substitution, right? I would let u be equal to 3 times theta, and then I would say, okay, well, where is the cosine of u equal to -1? And so on our unit circle, cosine is which coordinate? The x, and so x is going to be equal to -1 over here, which is what? Pi, right? So u is going to be equal to pi. I'm sorry? No, u is not equal to pi over 3. U is equal to pi. Because, right, so you can kind of think it logically through your head, or you can say, okay, well, let me go back to this. Pi is equal to 3 times theta. And so if I divide both sides by 3, pi over 3 is theta. Okay? But do we have any other solutions in 0 to 2 pi? So when is cosine going to be equal to -1 again? We're going to have to go 2 pi around, right? Right, so no, there's, well, hold on. Let's see. Pi over 3 plus, change that to thirds, so that would be 6 pi over 3, right? So no, because that would be 7 pi over 3, and that would be outside. Oh wait, would it? 7 pi over 3? Yeah, that would be outside of our domain. I believe pi over 3 is the only answer. Marasia, you okay? Was your problem exactly the same? Okay. Do you know what you did differently? The book approaches it a little bit differently than I do, but you should have still gotten the same answer.
Yeah, the example that you used, like the 26 example, that one had like 6 different answers. Yeah. So.
Okay. We want to remember here that our period is not 2 pi because we've got this little number right here. So in this example, we're going to take 2 pi and divide it by 3 to get our period. So it's 2 pi over 3. Okay, so I want to get this. Oh, it's already the same. So my answer was pi over 3. So if I add a 2 pi over 3 to that, I get 3 pi over 3, which is just pi. So that's going to be a solution. If I add another 2 pi over 3, I'm going to get 5 pi over 3, which is still in my 0 to 2 pi. But if I add it again, I'm going to be outside of that. So my solutions are pi over 3 pi and 5 pi over 3. Okay, does that make sense? Right? So we have to remember to look at the period when we use U substitution because the period's going to change. Okay, so I like U substitution, and if you get the hang of U substitution now, then when we have to use it in calculus, it's going to make a lot more sense. So if I take this equation and I substitute all that stuff, I substitute U for the stuff inside, that's equal to -1. How am I going to figure out my period? Pi over, really it's kind of 1/2 times theta, so it's 2 pi over 1/2, or 4 pi. When is tangent equal to -1? Tangent's +1 here, and it's +1 here, right? Because I got square root 2 over 2 and square root 2 over 2. These are both positive. Down here, they're both negative. So those 2 points have a positive negative, or a +1 tangent. So it must be this point right here and this point right here that have negative tangents. That makes sense? right? And so what is this value? What angle is that? This one's 1 pi over 4. Do you remember what this one is? Remember how pi over 4s go? So 1, 3, 5, and 7 pi over 4. So you need your unit circle if you don't know those things, right? You want to look at your unit circle and see where those places are. So u is going to equal 3 pi over 4, and u is going to equal 7 pi over 4. Oops, did I write down what u was anywhere? What did we let u be equal to? So theta over 2 plus pi over 4. So if 3 pi over 4 equals 1/2 theta plus pi over 4, and 7 pi over 4 equals 1/2 theta plus pi over 4. If I subtract pi over 4 here, I get 2 pi over 4 equals 1/2 theta. So multiply both sides times 2. And you're going to get theta equals pi. Subtract pi over 4 here. I've got 6 pi over 4. Multiply it by 2. See, 2 goes into 2 once. It goes into 4 twice. 2 goes into 2 once. It goes into 6 3 times. So I get pi and 3 pi. Did this problem ask us to find the solutions in the interval from 0 to 2 pi, and so do both of our solutions work? Just one of them works. Okay. And then number 10 is to just use your calculator to solve. Okay, we good?